So first let me introduce you to Tia. This is Tia. She's a rescue cat that we have, and she's not letting me record without giving her some attention, so I'm just going to pet her as I go through this lecture. So hopefully she'll stay mostly out of the video, and hopefully she won't distract you too much. So let's look at the last type of addition reaction that we're going to look at in chapter 13, which is addition of water to alkenes. Now water we know is polar and alkenes are nonpolar. So to get a reaction between this polar water and this nonpolar alkene, we have to add a catalyst. And if we look at this slide, we see the simplest alkene right here, which is ethylene, and when we add water to it, the catalyst is written above the arrow. So we'll always see that catalyst, and a catalyst is a chemical that is not used up during the chemical reaction, but it allows it to occur much more quickly. Alright, so let's look at how water is going to add across that double bond. So we are going to look at water as being HOH, and what's going to add is this hydrogen as well as this OH group. So this would be our X and OH would be our Y. So when we add water across a double bond, we're going to get an alcohol. Now let's focus back on ethylene, the simplest alkene. And one carbon in the double bond is going to singly bond to the hydrogen, and the other carbon in the double bond is going to singly bond to the OH. So we will always form an alcohol when we add water across that double bond, and that is known as hydration. When you see the term hydration, you're expected to know that we are adding water across a double bond to form an alcohol. Now we haven't gone over nomenclature of alcohols, so I'm not going to expect you to name the alcohols. They're just included on these slides just to prepare you for when we get to that chapter when we're naming alcohols. We can see that the alkane root is here, ethyl for 2 carbons. This is known as ethyl alcohol. So let's look at what happens when we have to add water across an asymmetric alkene. And by asymmetric, we mean that the 2 carbons have unequal number of hydrogen atoms. So if they have unequal number of hydrogen atoms, we are going to apply Markovnikov's rule. So this alkene on the slide is 2-methylpropene. And we see the 2 carbons in the double bond have unequal number of hydrogens. The carbon on the right has 2 hydrogens, whereas the carbon on the left has none. So because of this asymmetry, we can apply Markovnikov's rule, which states that the hydrogen in our water is going to preferentially bond to the carbon that has more hydrogen atoms. So when we determine the major product of this hydration reaction, we are going to place this hydrogen on the carbon that has more hydrogen, and the OH, or the alcohol functional group, or the hydroxyl, on the other carbon. So our main product is this carbon here, where the 2 carbon has the hydroxyl group bonded to it, because the 1 carbon is the carbon that bonded to the hydrogen, the sole hydrogen of the water. So the name here is given just to prepare you for when we name alcohols, 2-methyl-2-propanol. Of course, you would not be expected to name this, but just predict the major product if we are hydrating across an asymmetric alkene.